So the scenario that we're going to use for this demo is we're going to be playing two different roles here. The developer, which is Dev, actually in this case is going to be Mathieu. He doesn't look like Dev, but he's going to be playing that role. And it's basically showing how this developer owns this hybrid applications which runs on various environments, as well as having some components in ZOS. And what we want to show you is how a cloud-native developer has at her fingertips, or in this case, his fingertips, all the components and solutions necessary to not only build that solution, but also push it out to ZOS, which is a non-traditional set of skills that this developer may have. So you'll see how easy it is for even her to, or him to push this out to ZOS. Part of the demo will also be to show performance of the application in the context of a fit for purpose type of approach, or best fit approach, because that's also part of the developer's job, is not only to change the application but make sure that it's performing correctly. So again, we'll be showing you all these components one step at a time here. Mathieu, I will go ahead and click through this so we don't have to switch screens one more time. So I'll let you describe this flow right here.
Yeah, so this is the overall workflow that we will demo in a few minutes. The idea here, and we ended up with an architecture which seems to be complex, but the idea was to show the different cloud-native capabilities that we have for development and for deployment. So we basically ended up with two different sides. One is for the CI part, so for the pure development, and the other side is for the deployment. So that's why we ended up with that type of integration. So what I will do first in the demonstration is to actually clone and push the application source code from the Git repository into my developer workstation. And then I will run the user build using, through the RSCD started task. That's the IDC component on ZOS, and I will trigger the DBB toolkit to perform a build of my of the program that I'm supposed to change to fix the issue for that application. I think you can go ahead, yeah. And one more time. And then when I will do the changes, there is a feature in GitLab CI which is called Autodevops that will automatically run a pipeline when there is a change in my Git repository. So as soon as I commit my changes to my main repository in GitLab, a pipeline will be kicked off, and the pipeline will just go through a clone command using the ZOS Rocket Git client, and will perform. You can continue, Roberto, to click, and will perform then a build of the application and a build of only the component that changed between the previous version. So you can keep going. Yeah, and so my application will be built, and you will see that in the demonstration. All the building blocks will be also the building blocks that I show will be also part of the game. That is unit testing, code coverage, WASI analyze, and so on. And the last step of my stage will be actually the push of my changes to a GitHub instance that is sitting on the cloud, and that will make the integration with the rest of the infrastructure. So you can continue, Roberto.
Okay. So the right side of the picture here is the kind of like the application architecture as well as the flow, which we'll describe here in the next slide. So let me just click through that. And so this is how the application is architected. And the application is basically a Liberty Java-based front end. As you can see, it's running in 3 different environments. It's the same Liberty, same Java code, same everything. It's running on OpenShift on x86 off-prem on the IBM cloud in this particular case. It's also running right here in OpenShift on Linux on Z, which is running the same, it's running this in the same, in our case, the IBM Z14, it's running on the same keg, where my ZOSL part running my kicks, which is running the application, the COBOL backend to this front end, front application. And he all the components communicate through ZOS Connect. So they all send this, because again, it's the same application, they all send the same REST request to ZOS Connect, which then sends a request to COBOL, to kicks, to retrieve data from a vSAN file in this particular case, and then return it to the caller. The application is also running on this third environment, which is ZZX inside of ZOS. It's the same container, so the container running on OpenShift on Linux and C here, and the container that's running here inside of CCX is exactly the same one. Same binaries, because they're both S390X architecture. The container that's running here is exactly the same application, however, it's built on x86. So it is an x86 container. The building of these containers can be automated. It's very simple. But the point is that it's very simple to deploy the application on various locations. So what I'm going to do is I'm going to briefly explain what the flow of what's going to happen in the demo, as far as after Mathieu does his developer role. Once he executes his components to fix the code, and push it out to GitHub, there's a message that flows from GitHub to an event listener, which is running in OpenShift on Z, which will trigger a pipeline, which, as he described, it'll do a git clone to clone the code that was just changed. It'll install some dependencies to run the Ansible components, which will then send a message to ZOS, to the Ansible component in ZOS, to do some steps, which are going to compile and link the module. Bryant will talk about this a little bit more detail later. It will also do some CICS commands in order to push this module that has been fixed into CICS. Now, you'll see through the demo that this is done on the fly. Transactions that are in flight using the old module, finish using that module. Any new task that starts in CICS will pick up the new module. That's what is called the kicks phase in command. And we'll see the impact that how that happens in the application. So what I'm going to do first is I'm going to switch to the web front end of the application, which is, it's called mod resorts, as you can see here. So this particular instance is running on the, this is actually running in CCX. I can pick the one that's running on the public cloud. So let's just pick that one. They're all the same. So basically, it's a hotel front end. It's a hotel reservation front end. And I can pick any of these cities. And if I pick, for example, since I live in Miami, I'll pick Miami. I select that. And you notice that it comes back with some data and a picture of Miami, etc., the beach. I don't live in the beach, but I wish I could. Anyway, so there's the hotel information. This bit right here, the hotel name should be here, but as the developer sees, there's a debug message. So somebody was messing with the module. It didn't fix it before he or she left on vacation. There's also the rooms, the number of rooms, and the rate. This also comes from Kix. So this is a REST call that goes from the application to ZOS Connect to Kix, retrieve the data, and come back. The rest of the data, the weather, the temperature, etc., that can come from any other REST service from Google or any service in the cloud. So, but this is the issue. We have to fix this now. As I said before, part of the developer's job is to run performance testing, right? To make sure that when a change is made, some basic performance testing is done to make sure that you have not broken anything. So what I'm going to do is I'm going to use Jmeter. For those of you guys that may not know, Jmeter is just a way to robotically send traffic, in this case HTTP REST requests, to the application, which in turn sends to ZOS Connect, Kix, etc. And all I'm doing is just sending parallel requests to the CCX application. That's the container that's running in ZZX, the container that's running on x86, and the one that's running on OpenShift on Z. And before I show you that, actually, I want to show you this also. So let me just quickly, all the components that are part of this application, this ZOS Connect, the ZZX, the Kix, the application inside of Kix, they were all deployed by the developer, through what is called ZOS Cloud Broker. Cloud Broker is a way for the developer to have access to deploy, not only deploy, but also deprovision. Once I'm done with the testing or development or whatever, I can also deprovision. So she can, or he can, provision a Kix app server, the application that's running inside of Kix, a ZZX, etc. So all this, again, in a very just cloud-like manner, just click on the tile, and have automation in the background deploy those components. So what I'm going to do is I'm going to start the performance test, right, or the traffic test. It's 30 users, so there'll be 10 users per group. So I'll go ahead and crank it up right here. And I'll look at the table, make sure that everything is looking green. As you can see, he's starting to send. Now, remember, this has been driven from my laptop, just a tiny little laptop. So I cannot drive utilization very high, but this is just a basic throughput or performance test. And it's sending to all the different environments. You see x86, ZCX, OpenShift on C. There's a graph here that I can select which shows me the throughput based on each environment. And as you see, there's an OpenShift on C, it's the purple. The x86 performance is kind of like the teal color, and the ZCX is the dark blue. And as you can see, it's running about 2.4 or so transactions per second, which we know that's wrong. That's totally, that's not acceptable. There's something definitely wrong. So the developer now, with this in mind and the information that she or he sees here, he'll go and fix this issue. So with that, I'll turn it over to Mathieu for him to do that. Now he'll turn it back to me after he's done, and then I'll show you what's happening in the background. Okay. So Mathieu, I'll turn it over back to you.
Yep. Okay. So yeah, as you mentioned, Roberto, I will play the role of the developer here, who was emailed or contacted by the ops side of the application that is maintaining the application after there is this strange message and this performance issue on the application. So I'm using the GitLab platform to manage the lifecycle of my application and to develop new features. So first I will connect to that platform, and I have a set of projects, and I have the resort projects here. So that's the project which contains the source code of my resort application. And I can see that there are some pending issues. And this one, for instance, was open a few minutes ago when the performance issue was found and the debug message problem. So I can click on this one, and there are a set of labels attached to that issue. So what I can do, for instance, there are some also description here of the message. So debug message showing up and a poor performance. So I will first remove that flag here, and I will just add the doing one saying that I took over this issue and I'm working on it. I could also see the different issues in the board, so this is also a very convenient way, and I would be able to move the issues from one column to another and so on. So I could also do that, and it gives me a nice overview of the pending issues, the one that are assigned to me and the one which are still open and need some attention, and those are closed and so on. So back to my issue here. I select this one, and from this issue, there is something called the Gitlab Workflow. And in this workflow, you usually start from an issue and create a merge request from that issue. And by creating merge request, what it does is that it will automatically create a new branch, so I will call it feature 8, out of the source branch, which is called release. So release is, let's say it contains the source code of my application, which is running in pre-production or in production. So by doing this, I will create a branch which is called feature 8, because the number of my issue is the issue number 8, as you can see here. And it will automatically create a branch in GitLab for me to work in isolation from the other developers who are in charge of this application. And what it will do, I think I mentioned that, there is a feature in GitLab which is called Autodevops that will automatically trigger a pipeline, a CI/CD pipeline, when there is a change in my repository. So it can be the creation of a new merge request, and it can be a commit, or it can be a merge request that is that is merged to the initial branch. So if I click on the CI/CD section of GitLab, I should see a pipeline running for the new merge request that I created. So if we take a look at this pipeline, there are different stages, and this is related to the building blocks that I showed you earlier. There are some stages like the build phase, and in the build phase, I'm only building what I've changed. So today, I mean, right now, when I created this branch, there is nothing was changed, so nothing was built. But there are two other stages for the analysis. So again, the code review will do basically nothing because I changed nothing in my repository, but I still have the WASI analyze step here that I can click on this one. And what it does is that it kicks off a WASI analyze container with the sources of my resort application. So if I click on this link here, I opened it in a new tab, I can see the WASI analyze service with all the artifacts that I loaded into them. So that's all my programs, all my COBOL programs that are part of my application. And I know that I have one thing to change in my application to remove that debug message and increase the performance. And I have to implement a call between two programs, basically. So I know that the entry point of the program is of the transaction is this one, DFH0xCUI, and I need to add a link to another program which is called ICW. So I will need to change that, and I will also need to change another program which is called the VCR program, and I need to modify a few things in that file. So I will now switch to my favorite IDE, and in that case, I will switch to IDZ. I could use VS Code, I could use Red Hat Code Ready Workspaces, but I'm more comfortable with IDZ. So what I will do, I will first check out that branch, that new branch that was created for me. So I select switch to others, and on the remote side, oh, I forgot one thing. I need to fetch first the new information. So I select fetch from origin, and I see that there is this new branch that was created here. So I will switch to that branch, switch to other branch, and on the remote side, so that's on the GitLab server basically, I will double click, we'll check out this branch and check out as a new local branch. So a copy of this branch will be hosted on my developer workstation. And from that, I can start editing the file and so on. So as I said, I know I have a link. I have a call from one program, which is the CUI program, to the ICW program that I need to set up to fix the performance issue and the debug message. So I will just add here a call to the DFH0xICW COBOL program. So I need to do that. I will save the changes for this one. And for the VRC program, I need to edit it as well and comment some line. I think it's here. Yeah, I have some lines to comment here to make sure that the performance issue is solved. So let me just comment these lines here, and I will save the changes. So what I can do from my developer workstation here with IDZ is to actually build those programs to make sure that the changes I did don't break the compile and link edit steps. So I will do that using what we call a user build in IDZ. So it's leveraging the dependency-based build product. So everything is already pre-configured. So I just need to click on user build, and it will reach out to my ZOS machine, upload the necessary file, and run the build of this application. So this is the output that you can see directly in the console in IDZ. I can click on this one. I can see the build report that was created for me. So if I click on this one, I can see that I compiled the CUI COBOL file, and I can see all the results of my compilation. So there was an object file that's the COBOL program that was compiled, and I can see that there is a load module that was created in this dataset. And if I check again some additional information, so I can see that the build state is clean and one file was processed, which is the CUI file. So this one is okay, and I will try to do the same for the VRC program that I just modified. So I will run again a user build, and IDC will upload the necessary file to my ZOS machine, to my ZOS sandbox, and run again the DBB scripts. And I'm also satisfied with the result, as the build state is clean when one file was processed. That's the VRC. I can see it here. That's the VRC program that I modified. So I'm very happy with my change, and I'm confident that it will actually solve the performance issue and the debug message. So I will stage the changes, and I will just put a commit message. So fixed the issues, and I will push. So I will commit and push the changes to my GitLab repository. And if I switch back to GitLab, so here, and to my, let's switch back to my merge request, you will notice that there is a pipeline is automatically triggered. As I mentioned earlier, the Autodevops pipeline is triggering a new pipeline for every change in my merge request or in my repository. And this is what happened here. So you can see there, this pipeline is actually running for my feature branch here. So if I click to have some more details, I can see that now the build takes a bit longer because it's building all the files that I've changed. That is these two files, the VRC program and the CUI program. So I won't go through all the details because I've enabled the verbose version of the build. But what I can certainly show you is that if I found them, yeah, I can see that there are several impacted files by my change. So first, the CUI file is rebuilt, and the VRC file is rebuilt here. And my build step contains unit testings, so using the Z-unit feature of IDC. So that's why I have additional files added to my build list in DBB. And if I scroll down a bit, you will notice that there is here a JCL that was submitted as part of the build, which is called run Z-unit. So it's actually using the dynamic test runner on ZOS, and I'm actually running a unit test for the VRC program here. And the result of this unit test is that actually I passed that test here. So my test was successful, which is very helpful as a developer. So I know that I didn't break anything by performing that change on the VRC file. As part of the unit test, also the code coverage information was collected for that program. So that's also a very interesting feature that I can leverage in my pipeline. And one PDF file was automatically created for the VRC program, and I have some information on the lines that were actually executed as part of the unit test. So I can see that information for the different paragraphs in my COBOL file, and I see the breakdown. So that's for the different paragraph, and I can also see the breakdown by each line. So there will be there is a green mark in front of the lines that were executed, and a red mark in front of the line that were not executed. So that gives me a good understanding of the efficiency of my test, if I passed all the necessary, all the important paragraphs and lines in my COBOL program and so on. So if I continue the execution of my pipeline, so now it's done, but let me just switch to the WASI analyze part. And again, a new container was kicked off as part of this pipeline. So I can open this new container here, and I can see the difference because I also changed, if you remember correctly, I also implemented a call between two different programs here. So if I check the CUI program, I should see that there is now a link to the ICW program. So if I compare with the previous version of the same program, the CUI program, that was the initial state. So the CUI was only calling the ECC program. And now with the change I did, it's also calling the ICW program. So I'm pretty happy with that. And the benefit is that I could immediately see the benefits or the results of my change in the structure of my application using WASI Analyze. So as part of the analysis stage of my pipeline, I can take a look at the code review phase, which is leveraging the IDC feature, IDC Code Review feature. And what it does is that it compares the content of my source file, of my source code. So in that case, the VRC1 and the CUI1, it's checking against the set of rules that I've defined to actually perform syntax checking and code quality against these two files that I've changed. Let me just show you now some interesting result that I've got. So you will notice there is a tab here which is called test, and either the unit testing feature or the code review feature are able to generate JUnit compatible report that can be used and that can be very easily integrated into the GitLab platform. So I can have some results that I can easily browse here. So if I click, for instance, on the unit, on the ZUnit test, I can see that my test for the DFH VRC load module, the name of the test is called test2, and it was passed successfully. I can eventually view some more details. Well, not for this one because it's successful, but if I have a failure for instance, for the code review, I have some tests that fail 24 out of 30, so I'm not a very good developer here. I made some mistakes. And I can see, for instance, some more information for instance, a cyclomatic complexity. I could have some more details here and try to make some change to improve that metric. So both the code review and the unit test are able to generate these reports, and that can be easily displayed through the GitLab platform. So I actually made my changes and I'm pretty happy with that. So let's go back to my merge request, and actually I'm done as a developer because I was able to perform the required changes. I went through some unit testing, and the code review and the WASI analyze features show me that the changes are okay. So what I can do, I'm able to mark this merge request as ready, allowing an approver to take a look and finally merge this branch into the release branch of my application. So this is typically done by, let's say, a release manager, but for the sake of the demonstration, I will do this myself. So as you can see here, there is this merge button that appeared. So if I click on this one, I will ask the GitLab platform to merge the feature 8 branch into the release branch. And that will also automatically trigger a pipeline here on the release branch now. And you will notice that this pipeline is a bit different from the one that is running for my branch. It has an additional step here, which is called publish. And this is where we are actually doing the connection with the deployment environment that for which Roberto is in charge. So I will actually start again by rebuilding my my ZOS software artifacts that are the two programs that I've changed, the VRC program and the CUI program. I will also run through a Z-unit test to make sure that when it was integrated in the release branch, nothing was broken and they all behave as expected. So I'm done here for the build phase and the Z-unit phase. If I check on the analysis phase, you will notice that only the code review now is running. So we don't kick off a WASI analyze container for that release build. And the WASI analyze, the code review step will actually, again, check against the set of rules that I've defined to check if my code is meeting the expected quality. So yeah, that's running here. As you can see, it's using the CUI program and the VRC program. It's also using the test case here, the unit test case, but we don't really worry about this. So now it's done, and I will switch to the publish phase, which is a new phase that is part of my pipeline. And the purpose of this, there are two different steps in this stage. The first one is, as you can see, it's called Artifactory, and the purpose of this stage is to actually package my application and push it to an Artifactory server, so an artifact repository for archiving purpose, or that would be also that could be used also as a bridge to a deployment platform. But it's also publishing the changes to my GitHub platform, and this is what you are actually seeing. And it will automatically trigger, thanks to a webhook, the deployment pipeline. So in a few seconds, when it's done, I will turn over to Roberto for him to share his screen and show you the pipeline. So now it's done. So back to you, Roberto.
Yeah, it's running the pipeline. So share, if you can put my screen on, Kevin. Let me know when you see it. Can you see my screen now?
Yeah.
Okay. So here's a pipeline that got triggered. As the result of what Matthew was doing. And what I would like you to notice is, I mean, it's going through step by step, so we can click on here and you can see the steps that are happening on the on my side, on the ZOS side. And I'll also show you the result. I mean, the Jmeter test is still running, as you can see, it's still running about 2 or so transactions per second. But the pipeline, what's going to do is, as I showed you before, he's going to install some Ansible collections. This is all containerized, right? Everything that's happening here is happening in containers, and with some automation that Ansible is triggering on the ZOS side. So you'll see that it's installing those Ansible collections. It'll take just 1 second. And Bryant, feel free to chime in and comment in this step. So it's installing the Ansible dependencies.
Yep, exactly. And what this is doing, like Robert mentioned, are that these are all running in containers themselves. The collections themselves are being pulled down from Ansible Galaxy, the public repository out there, and it's pulling down a couple different collections here. We're using the IBM ZOS core collection as well as the IBM ZOS Kicks collection as well to perform some of this deployment tasks here.
And you'll notice, I want you to keep an eye on the transactions per second here as the pipeline finishes. Here we go. So it's compiling a link, ready to push the module to production, or to, in this case, to our test environment. And as you see, I mean, I think this is pretty awesome, right? As soon as the Ansible playbook executed the step to go ahead and push that new module to production, the one that that Mathieu fixed, you notice how it immediately has an impact on the throughput of those transactions that were in flight, right? As I told you, the ones that were using the old module finish that task. The new ones that start through the Jmeter test, they will pick up the new module. And there's a couple of things to notice here, right? As I told you before, the application is running in 3 different environments, but the backend system, the system of record that has the business logic as well as the data, is running on a Z environment. Now, The OCP on Z, you see the throughput of the teal, which is the x86, a container running x86, is furthest away from that system of record. Therefore, he's only running about 240 or 40 or so transactions per second, where the CCX, as well as the OpenShift on Z that are located on the same CAC, on the same physical frame, they're running about 450 or so. So it's about twice the throughput because of the latency, right? The further the calling container is, the more routers, switches, cables, etc. has to go through, and that has an impact on performance. So the takeaways here are a couple. I mean, I want you to understand that you can run the application anywhere, but co-location is always best, right? Closer, bring the applications closer to the data. OpenShift allows you to do that. And the other takeaway is, as the developer, the cloud native developer, you don't have to get a TSO, ISPF, to do the traditional steps to compile link an application, much less to deploy that application into the run and kicks region. Okay, so I think that's a pretty powerful message and allows agility and a way to run things faster, better, more efficiently. So with that, I will turn it back over to, I think, Sherry, right?
And can you share my screen, Brian? Thank you. So basically, what we want to have you take away from this, and please, if you have any questions, put them in the chat, are three basic things. First of all, hopefully you got to feel that, which is our vision, that IBM Z is a vibrant choice of platform for a hybrid multi-cloud world. It has some qualities of service that can't be beat. And as Roberto mentioned, the co-location of having your data and transactions on the same system just increase that throughput. Second thing is, using standardized tools and processes can deliver business agility. And you saw, I'm sure, all of the many standard, capabilities as far as Gitlab and using Jmeter and, some of our open source tools that developers are familiar with, and just using the best tool for the job. And then lastly, that should lead you to, the takeaway that, hey, this development, this hybrid cloud development, you don't need specialized mainframe skills to do this.